Hey, what's going on, guys? Here, this question is asking to find whether this series converge or diverge using ratio test. So, first of all, we have to take this one limit n approaches infinity an plus 1 over an and check whether this is less than 1, equal to 1, or greater than 1. If it's less than 1, it converges, equal to 1, no conclusion. If it's greater than 1, it diverges. So let's see how we can find it. So first of all, we are going to take this is going to be a absolute value of the limit, right? So let's take the limit n goes to infinity. So when you take the absolute value, this will go away, because if you take absolute value, this is going to be positive 1, and positive 1 to the power of anything is going to be 1. So we don't even have to put this one, we just have to put this one right here. So here, the first thing we are going to do is we are going to add 1 to every n we have. So in this case, we have n right here. This is going to be n plus 1 square. And we have 2 power n right here. That's going to become 2 power n plus 1. And in the denominator, we have n factorial. And this is going to be n plus 1 factorial, right? And then we divide this one by this original function. That's what an means, right? This original function. But when we divide this one by original function, it's dividing this one by original function is same as multiplying this one, the reciprocal of this one, right? Dividing by this one and multiplying by the reciprocal of it is same thing. So here, instead of dividing, I multiply this the reciprocal of this one. That's going to be n factorial over n square times 2 power n. Now, to make everything easier, what we can do, we can arrange them in an order, like factorial in one thing and 2 powers one thing, and let's see. So we get limit n approaches infinity. First of all, let's arrange this n powers. So n plus 1 square, and in the denominator we have n square, so let's put them together. And the next thing we have is 2 power n plus 1, and we have 2 power n in the denominator. Let's put them together. And again we have n factorial in the numerator, and in the denominator we have n plus 1 factorial, right? So let's see how we can cancel some of those. So first thing, we can see this one, like 2 power n plus 1 is same as 2 power n multiplied by 2 power 1. So it means we can cancel this one. We are left with 2 power 1. So this is 2 power 1. And then n factorial over n plus 1 factorial. So let's say this is 20 factorial, 21 factorial. So what's going to happen is 20 factorial, 21 factorial, 7 factorial, 8 factorial, or you can think about anything. Like factorial is going to be reduced by 1 each time, right? So this is going to go like n minus 1, n minus 2, and n plus 1 is going to go like n plus 1, n minus 1. So after n plus 1, everything else is going to be same as this n. So we can cancel this n factorial with the denominator factorial, because after this n plus 1 factorial, everything else is going to be same as n factorial. So we can cancel that one, and we only have n plus 1 left. And let's see what we can do with this right here. And let's put them together in a different way. So here we are going to have limit n approaches infinity, and whatever the things we have left is n plus 1 square over n square times n plus 1. So this is the only values that is left. And if you see, in the numerator we have n square, and in the denominator, if we multiply, this is going to be n cubed. And also we have a 2 power 1, we can bring that 2 to the front. So this is going to be 2 multiplied by these values. right? So let's put the 2 bracket maybe. Okay, now if you see this n square and this n cube, so whenever we have highest power in the denominator, this will make, this is going to be infinity, and but this is much higher than this, therefore this will become 0. When you have highest power in the denominator, that's going to be 0. So here the limit for this one is going to be 0. 2 multiplied by 0, that's going to be 0. And you can see this is less than 1, right? So this is less than 1, therefore this is convergent. Converges, therefore this is absolutely convergent or convergent series. You can say both of them. This is a convergent series, and that's how we do this kind of problems. I hope you guys find this video helpful. See you next time.